Our topic for today is going to be Unit 1.3, Day 1, and we're going to be talking about today arithmetic sequences. So we're going to kind of delve into some new territory. Some of this might seem familiar to you and some of it might not. We'll see as we go forward. And as we have been in the past, kind of our objective today is to identify the characteristics. And so that's really going to be the big thing, the characteristics of an arithmetic sequences. And later we're going to talk about geometric sequences. And we're going to write what we call recursive and explicit formulas for arithmetic sequences. And as always, we start with some vocab of things that we may or may not be aware of. So the first one is a sequence. And a sequence is basically an ordered list of numbers. And so whenever we have a list of numbers, in some cases they're just random numbers put together, but in this case we're going to have them ordered in a particular way. So they'll have the first one, the second one, the third one, and they'll have a particular pattern to them. A term is each basically position, or basically each number in a sequence. And we always kind of start with the number 1. So whenever we order these, we always start at 1 counting. Now there are some instances where we start at other numbers, but in this case it's each position in the sequence, or basically each number in the sequence. Now with an arithmetic sequence, it's an ordered list of numbers, just like our kind of definition of sequence, but it has what we call a constant difference between consecutive terms. Now, I'm really big on kind of the root of some of the words that we look at. So when we look at a word like difference, what that technically would mean would be subtraction, but also it can mean addition, because we kind of know that those two things are the same. Now with the geometric sequence, it's still, again, an ordered list of numbers, but this time instead of a constant difference, we're going to have it called a constant ratio between consecutive terms. Now when we think of the word ratio, what we should be thinking of are words like fraction, but what that's going to bring us to is really multiplication and division, because that's how we can create fractions and work with fractions, is with multiplication and division. So we have arithmetic sequences that deal with addition and subtraction, and geometric sequences that deal with multiplication and division. And then finally what we have for our last vocab is something that we call the nth term. It's just kind of this mysterious term, and we're going to talk about this, but it's the term. So this is representing of the term of a sequence in the nth position. So it's basically that particular number that we don't know of. So for example, if I had, my first term, that would mean that my n was equal to 1. But the idea is that's just this unknown value, or not necessarily value, but this unknown position in my sequence. And so basically what I need to do is I need to recognize arithmetic sequences. Some people call it arithmetic. I call it arithmetic sequences. But we have to understand that there's this thing that we call the common difference, and we're going to label that with a lowercase d. Now the idea with this common difference is that it's this value that we're either adding or subtracting from one term to the next. And so let's look at these two sequences to see if they are in fact arithmetic sequences or not. And really, like I said, the idea is there any addition or any subtraction going on from each term? So let's look at the first one. So as we move from 2 to 4 to 4 to 8 to 8 to 16. Now immediately when we think of arithmetic sequences, we should be looking for addition and subtraction. So between the first two, you plus 2, plus 4, and then plus 8. The idea is that this is a common difference. It has to be the same each time. So basically this one here, since it's not the same, is not arithmetic. Now let's take a look at the second one. So the other one, we go to 48 to 45, so that's minus 3, and then minus 3 again, and then minus 3 again. If this pattern keeps going, we can see that we're probably going to be subtracting every time. So this is yes, this is arithmetic. And what we're basically going to say is that the common difference is equal to negative 3. So that common difference is kind of that value that it's equal to, or that it's either adding or subtracting every time. And so the idea here is what we talked about, the nth term of an arithmetic sequence when n is equal to 7. This is basically saying find the 7th term. And so with this case, if we just kind of use our logic here, we have 4 terms already. So we have 48, 45, 42, 39. And if we keep going with that pattern, we would end up finding our 7th term, which in this case ends up being 30. So the idea is that we can just continue on patterns, by finding what they have in common, and as how those terms are kind of changing is what we call our common difference. All right, and so now what we're going to run into is, now that we can identify an arithmetic sequence based on whether we're adding something to it or subtracting it, what we're going to do is we're going to be able to define two formulas. So we have two formulas here that correspond to arithmetic sequences. The first one is what we call a recursive formula, and then the second one is what we call an explicit formula. Now if we look at the first one, the recursive formula, what we basically use this one for is to find a term when I know the previous term and the common difference. Basically what that is saying is kind of what I did on the last slide. We knew the term, we knew the common difference, and so if I know the term before it, I can find the one after it by just applying the common difference. So for example, if I just had something as simple as 1, 2, 3, and I asked you to find out what came next, you would look at 3, say, hey, we're adding 1 every time, and so I would know my next term would be 4. And that's kind of the basis of what this, recursive formula is going to do. And so if we take a look, here is our recursive formula in kind of all its glory here. So there's a couple things happening here. The first one is, this is the term that I want. And I can just call that any term. That's a sub n. That's just any term that I want to know. And that n that's at the bottom corresponds to the term number. So for example, if n was 7, I would want to know a sub 7, which would stand for the 7th term. Now if I look at the rest of this, a sub n minus 1, if n is the term that I want, what this means is n minus 1, and so this is going to correspond with the previous term. So anytime you see a sub n, that's the term that you want. A sub n minus 1 is the term right before that. And then finally what we have is this, and that is our common difference. And so we can just go ahead and label that common difference. And that's basically what we're doing. So if we kind of look at our formula, we're going to take the previous term, add our common difference, and that's going to give us any term that I want. So you give me a term, or you give me that term, I tell you what the common difference is, and I can tell you the term immediately after that. Kind of like that 1, 2, 3, 4 example. You gave me 3, told me you're adding every time, I could tell you that the next one is 4. Alright, so now we're going to move on to our explicit formula, which is kind of similar to it, but the idea is that this allows us to find any term that we want, regardless of what came before it, as long as we know what the first term is and what the common difference is. So the idea is that this helps me create, the recursive formula at least helps me create a list. The explicit formula is going to help me find any term that I want. So if we take a look at what this is, the explicit formula kind of gives me a little bit more information, but the idea is this is still the same. This is the term that I want. So a sub n is my desired term. And then we're introducing a sub 1. Now a sub 1 is, if we look at kind of back there, with a sub n, n was any number, I plug in a 1, that's going to represent my first term. We still have our common difference over here. So I'll just abbreviate that common difference. And then the last piece here is this n minus 1. The idea is that we're finding the number of common differences that happen between the first one and the term that we want, but we always subtract 1 because we already counted for one of these. So this is our explicit formula to help us find any term that we want. We take our first term, as long as we know what that is, and then we take n minus 1, so n would be what term that I want. So if we use the term over here, 7th, I would take 7 minus 1 and then times that by d, and that will give us our explicit formula. And so the whole idea with any formula is just basically to use that and to kind of, have it in place so that we can just plug in the things that we know. So really, writing these formulas isn't anything that's too difficult. So if we look at the steps that are involved, the first one is determine whether our sequence is arithmetic or not. Because if it's not arithmetic, I don't have to do anything with it. The second thing is I'm going to identify the common difference. Part of determining whether a sequence is arithmetic or not is basically going to determine the common difference. So steps 1 and 2 basically happen at the same time. Because if I can find a common difference, it's arithmetic. If I can't find a common difference, then it's not arithmetic. And then the next thing is I'm going to identify the first term. Whether I'm going to use it or not, it doesn't matter. Still should probably have it. And then I'm going to substitute into whichever formula that I want. So let's take a look at how this works. So I have a sequence up here of 9, 0, 9, and 18. So because it's arithmetic, I should be looking for addition and subtraction. So as I go from here, we're adding 9 again, and then adding 9 again. Now if you can see that you're adding 9, you can immediately say that my common difference is 9. And so we can just kind of jump right to that. And so here, first part is identifying that this is arithmetic. So yes, this is arithmetic. And the common difference in this case is 9. So D equals 9. So I'm going to identify my first term. So I'm going to call that A sub 1 is equal to, in this case, negative 9, because that's my first term. And now I'm going to write my two formulas. And so the whole idea is that we're not going to have every single piece of information, but we can at least plug them into the formulas. So if I look back at my recursive formula starts like this. A sub n equals the term before, which is a sub n minus 1, and then plus our common difference, which is 9. And so here's our formula. So you tell me which term that you want. You tell me what a sub 1 is, which we don't know yet. So if I wanted to know the fifth term, you could plug in 18 into the formula right here, add 9 to it, and then it'll give you your fifth term. The next one is going to be our explicit. If we look back at our explicit formula, we're going to use, again, a sub n, so any term that I want, equals my first term, which happens to be negative 9, plus n minus 1, because we don't know what n is yet, and then times 9. And so if we look at these, they kind of have similar elements, but the idea is we're still waiting on n in order to figure anything else out. So that's how we write our recursive and explicit formulas, by just simply determining our common difference and our first term, and then just substituting what we know into our formulas. And then just one last example as we look through that, just remind of your steps. But the idea is as we go from term to term, we're looking for what they have in common. And with this one, what I'm doing is I'm subtracting 1/3 every time. So it can still be fractions. And so I'm subtracting 1/3 every time, so my common difference is negative 1/3. And my first term, a sub 1, would be negative 1. And so if I was to write my two formulas, my recursive would simply be a sub n equals, and then I look at a sub n minus 1, so you have to tell me my previous term first, and then plus my common difference of negative 1/3. Now if I was to write my explicit, a sub n equals my first term, a sub 1, negative 1, plus n minus 1, since I still don't know n, times negative 1/3. And so we'll look at how we can identify these terms in class, but the idea is at least you can write the formulas and plug in the information that you're going to need. And then finally, just a side note, just a couple of things that we're going to want to make sure that we know. A sub n is any term, and that number is n. A sub 1 is my first term. N is just a value. It's the number that we want. So it's going to reference a term, but the idea is we use a sub n to talk about the term. A sub 1 would be the previous term. And then the lowercase d is our common difference. And so that's going to basically wrap it up for these sequences, and we'll work a little bit more with this in class.